Alrighty, hello, my name is Daniel Lunsford and this is my Physics2212Lab1 charge tape presentation. So for the introduction, purpose, and description of this lab was to use tape in order to observe the transfer of electrons between material to calculate a rough estimate of the charge and number of electrons transferred. The goals were to use the data from a lab experiment to simulate interactions between 2-point charges in a closed script program. And some of the key concepts were assuming the tape had an equally distributed charge in order to treat each piece of tape as a point charge, making it possible to apply Coulomb's law. Applying Newton's second law, F equals ma, and Coulomb's law, F equals kq1 q2 over r squared, and using the approximate dimensions of an atom to calculate the number of excess or deficient electrons per atom on a piece of charged tape. So for models and assumptions, each piece of tape was used to model a point charge in order to observe interactions between them on a macro scale. Some of the assumptions we made were treating a piece of tape as if it was a point charge with the charge concentrated at the center of each piece of tape. Air resistance was negligible, and we also assumed that each piece of tape had about the same charge, evenly distributed along the length of the tape. So we were to create two U-tapes by placing one on top of the table and then ripping one up from that piece of tape on top of the table, and then observing the interactions between the U-tape and charged plastic objects. We were then supposed to make another one and suspend one of them at a level height, and then hold one of them underneath the suspended U-tape and observe interactions between the two. So results here, the charged pieces of tape repelled each other. The tape was attracted to both my hand and a neutrally charged book. The tape was also attracted to a negatively charged pen, and from there we could assume that the tape was positively charged. Calculated charge was 1.344 times 10 to the negative 8 coulombs. Each piece of tape was determined to be deficient of roughly 8.403 times 10 to the 10 electrons. So here are some of the data and calculations: the mass of the tape, the length of the tape, the width of the tape, and then the distance between the two pieces of tape. So the force of gravity here, F equals ma, was equal to the mass of the tape times the acceleration due to gravity, and that came out to be 0.001862 newtons. And then from there, from the experiment, we could assume that the force of gravity and the electric force were equal because the top tape was not accelerating downward. And from there, we calculated the electric force. Data and calculations: the number of electrons lost was the tape charge divided by the charge of electrons, which was 7.99 times 10 to the 10 electrons. The area of the tape, which was 0.04 meters squared. The area of the atom, which was the given atom length squared, which was 1 times 10 to the negative 20 meters squared. And the number of atoms on each piece of tape was the area of the tape divided by the area of the atom, which was 4.03 times 10 to the 17 atoms, and the ratio was 5.04 times 10 to the 6 atoms for every electron on each piece of tape. Here's my glow script model. The orange arrow is the electric force, the green is the force due to gravity, the red sphere is the top piece of tape, and the blue sphere is the bottom. So some model discrepancies: the pieces of tape were not true point charges, and the total charges on each piece of tape were likely not equal. Some sources of error here: unequal charges on each tape may not have been the same, and some charge on the tape may have been lost due to handling it, as well as general atmosphere of the classroom. So what if electrons had positive charge and protons had negative charge? What would change? I don't believe anything would change. By convention, we've given things positive and negative charge. It would still hold that like charges repel and opposite charges attract. And why is it important to handle the charged tapes as little as possible? This is because there's a constant flow of electrons between objects, and objects tend to want to be neutral. So if you're constantly handling the tape, they will become neutral, and the experiment won't really work. So some of the conclusions here were that we can use everyday objects to observe electric interactions, and everything around us is sort of participating in a sea of electric exchange, constantly moving toward a desired state of equilibrium. Alrighty, that's my presentation. Thank you.